Pavoni friends, John Hauk here. We're going to talk a little bit about the dual pressure stat for the La Pavoni. You can follow along if you go to bit.ly, so bit.ly / La Pavoni, as I've got there with capital L, capital P. And it will take you to a screen kind of like this where you can check out this, what I'm showing you on your own. So what I'm going to be talking about is we'll first take a look at the EuroPicola version 3. And it comes with a power switch that's essentially an on-off and a green light. And what happens is this unit then will heat to a particular temperature, typically about 7.7 to 0.8 bar. Of pressure in the boiler is how it works, and we use that both for brewing espresso and for steaming milk. And there's an upgrade available at Coffee Sensor where you can upgrade it with a dual range pressure switch, and you can see that the switch here changed, and there's an on-off switch, and then there's a low-high switch. So we've had low-high switches in previous generations of La Pavonis. Generation 2 had some of those at some point. The difference is today's La Pavonis only have a single heating element. The way the low-high worked on the previous La Pavonis is they had two heating elements inside. So we're back to a low-high, but with a single heating element. So how does that work, and how is this wired up? So let's take a look at the bottom of the La Pavoni with the dual pressure switch. And in fact, let's go back to the one with a single pressure switch. So you can see here generally how this works is there's a switch here that's connected to the boiler, and this turns on and off, connects these two wires on and off based on the pressure inside the boiler. And if the pressure is too low, it will turn the switch on. And if the pressure is too high, it'll turn the switch off. And that's kind of how it regulates the heat. So we're not going to go into the details of how that is wired up, but we will go into the details of the dual range. And so you can see the switch changes, and now all of a sudden we have two switches on this pressure stat. So again, it's monitoring pressure inside the boiler, and at a low pressure it turns this switch on, and at a higher pressure, and you can kind of see this is raised a little higher, it turns this switch on. So how do you use that to create a dual range, and how do you then incorporate this low-high switch along with the on-off switch in your wiring? So that's what I'm going to take you through. The first thing is the yellow wires here are for grounding. We just go ahead and cover those because those are kind of a safety requirement. Run your grounding wire, make sure that you're grounding the base of the unit, and then make sure that you're grounding the boiler of the unit, so that way if there's any short, that electricity will find its way back to the source and trip a breaker. All right, so let's follow we've got two phases here. Some people say neutral and hot, but if you're in European countries, they're both off of neutral. So we'll just call the brown and the blue. Those two connected together gives us power. So we got a brown wire coming in here, and it follows its way to the center of the low-high switch. And so the way this works then is if the low-high switch is set to low, as it is here, then it will connect the brown wire here with what I've colored a green wire. And so that green wire then goes to this pressure switch, and if the pressure is below, close to zero or no pressure, then it will connect these two, and then if the pressure hits about 0.7 bar, then it will turn the switch off. So if this is set to low, and we run our green wire through here, and then that wire then finds itself to the heating element, which is one side of the heating element. And so we've supplied the brown wire to the heating element if the pressure is low. And then once the pressure hits about 0.7 bar, the switch will turn off. Now, if you place this rocker switch here into the number 2 position, then instead of energizing the green wire, we energize the red wire. which goes through the higher pressure switch, which then will require the boiler to reach a higher pressure before it will turn off. And if the boiler is below the higher pressure, then of course the power, the brown wire power comes here through the red, comes out through the red of that switch here, and then goes to the same place where the green wire goes, which is this side of the heating element. That's essentially it for tracing the brown leg of our power, except for there's this little white wire here, which could be connected here. It could be connected here. It could be connected here. It could be connected here, just as long as it's in one of those four places to supply. What are we supplying? We're supplying the light. So if either of these two switches are on, it's going to power one leg of the light that illuminates this red switch here. That's really all the white wire does. You don't really need it, but if you want to know if it's heating up, that light will be on while one of these switches is open while it's heating up, and that'll indicate that the heating element is receiving power. All right, so let's step back, think about that, and now let's go ahead and dive into the blue wire. The blue wire, the other phase of the electricity coming in, it goes to the on-off switch. So you can see the blue wire here going to the center. Again, here's the brown wire lead from the switches. So when you have power turned on, you're going to see both of those coming together to illuminate your light. So we have wire power coming in here, and then when you turn it on, then that blue phase comes back out of the switch over here. So it's basically an on-off switch for this blue wire. And so then goes through the thermal fuse, which if this pops because the boiler is too hot, you need to reset it with this red switch reset button. And then the blue phase of the power comes in and goes to the other side of the heating element in the boiler. That is essentially it. That's really all that's required. I think the one thing to point out is that these are double pull, double throw switches here, or single pull, double throw switches. And so these would be energized when the boiler is reached its temperature. So that's really not going to be helpful. So don't use those. It does matter which one of these two you choose. Choose the one that's furthest away from the other lug, which is on the top, which is the bendy part. I think that's it. So that's how you convert version 3 Le Pavoni to a dual heated Le Pavoni. Go ahead and reach out to Coffee Sensor and grab those parts and get your wire going. I hope that's been helpful, and I'll talk to you guys later. Bye-bye.